This Torah class is brought to you by TorahAnytime.com.
Welcome everybody, welcome all our Torah Anytime viewers. Tonight's class is a good one, is a tough one. It's evolution. The idea of evolution, let's think of it like this. There was once a little kid who walks over to his father and he goes, "Dad, where do we come from?" And his father looks at him, takes his pipe out, picks up his glasses, and he says, "My son, we come from, the apes and other species." So he goes, "Okay, cool." And then he goes to his mother, and he says, "Mom, where do we come from?" And she says, "Why, my darling, we come from God's creation. God created us." So like any good child, he says, "Well, Dad said that we came from apes." And the mother says, "True, he's talking about his family. I'm talking about my family." So when we're going to be dealing about issues about evolution, it's a very touchy subject for some people. Some people get and you'll soon see why I, and amongst other people also, call evolution a sort of a religion. People believe it with such emunah, such faith in evolution, that everything will happen, in the sense of evolution. So when you go and you study evolution, not that you should, but have you had, if you did, some ideas that we're going to discuss on it. When you read it, you're like, okay, this can make sense. And then you could read it again, and then you'd be like, this makes absolutely zero sense. How did they even come into this? And it really depends on what angle you're coming from. There are some information about evolution that is very, very, very much misrepresentative, and which we'll discuss that. There is also a lot of questions that they have on evolution, which is not that often discussed. A big problem that I have with it, in many places it is taught as a fact, not as a theory. And we'll soon see, evolution is a very broad term. There's many aspects to look at it. Some of it may be a fact, and some of it is very, very, very much a theory and nothing else. One of the reasons why I like bringing this topic up is we tend to sort of just trust science. When you hear about science, the questions that I get will be like, well, science says this. What about the Torah? What does the Torah say? And I have to go and now defend the Torah against science. Now, there's one thing that you have to learn, and we'll B'ezrat Hashem learn over the course of this series, is that the Torah never changes. The Torah is unchanging, it always stays exactly the same. Science is always evolving, always changing. When you have a constant and when you have a variable, what do you judge against what? You look at the constant, you look at what's unchanging, and then you see if it matches against the thing that's changing. For some reason in our generation, we look at it the other way around. We're like, no, but science says this. Like, science says so many different things. Every day they change their mind, depending what pills they took the night before, how depressed they were, and what in the mood they are, and then they change the thing. I'm joking. Obviously they have, theories and background and, and evidence, but we'll soon see how far this evidence takes them. Other people use evolution as an excuse. Be like, God didn't have to create the world, because we evolved from nothing. We evolved from a bacteria. We evolved from monkeys. You're sort of taking God out of the equation. We'll actually soon see, B'ezrat Hashem, that when you look at evolution, you could look at it as it leads away to God, or you could actually look at it how it leads to God. When we'll speak about the probability, when we'll speak about the possibility of things happen, you'll realize and you'll see there is very little that this can happen. Thank you very much. You read my mind. Okay, what would we do without you? I don't know. I'll be very thirsty. Alright, that's one thing. Okay, so another important aspect to keep in mind is there are possible solutions to a problem and there are probable solutions to a problem. We spoke about this last week. The idea is this cup of water, well, I didn't see, this cup of water is a bad example. The example that I used last week, you see this nice beautiful spread that you have in front of you. You have the sushi, the chips, all the brachot that you could possibly think of, you have right in front of you. When you walked in here, say you didn't see somebody set up, you did not think that aliens broke in and set it up and now you have this beautiful thing. You think that somebody came before and set it up. Now, aliens, is it totally improbable? Yeah, well, if you don't believe in aliens, yeah. But let's say illegal aliens. Maybe they're the ones that came over here and set everything up. Now, is it likely? Is it possible? It's very possible. It's just not probable. Why would they come here? Why would they, maybe they got the ad and they saw it and they said, listen, it's an interesting class. We don't want to attend because we believe in evolution, but we're going to set it up. Very possible, but not probable. So we're going to look at the probable the probable solutions for ideas and not the possible solutions for ideas. Possible solutions, we can come up with, out of our head, millions of them. Okay, so now with that introduction we can begin. We first have to understand what science says. When dealing with science, and this is something that I get pretty often, people come and they'll say, oh yeah? Well, science says this. And I'll be like, no it doesn't, because you don't know what science says, because you're just mimicking what somebody told you science says. If you look what science says, science does not say that. People like to copy. People like to think of themselves as philosophers, as scientists, and if you actually study the material, it's very different from what we actually understand it. So let's try to understand what evolution is in the scientific verbiage of it. So, we know there is an idea called mutations. You have something that can mutate, it could change into something else. The way that evolution works is like this. There is mutation we know is possible. We know, and I'm not talking about you become like Spider-Man or you become, I don't know what's popular now, I'm sorry. But there's, whatever this action hero is, like something that you all of a sudden can shoot, because you got bitten by a spider, now you could all climb on walls. First of all, don't get bitten by spiders, because it's very likely you'll probably get infected and possibly die, depending on the spider. Don't think that all of a sudden you're going to start climbing on walls. But mutations can occur, and they do occur. So the way that they explain like this is the evolution. There are some times that they'll have a mutation. Now, this mutation can be one of three things. It could either be beneficial, it could either be harmful, or it could either be neutral. Neutral doesn't matter, we don't need to care about it, we'll put it on the side. If it is harmful for the species or whatever, the bacteria, whatever we're talking about, if the mutation is harmful, it's going to die out, it's not going to survive, because it's harmful, it's going to die out. If it is beneficial, then that species is going to become stronger than everybody else. It's going to be the Spider-Man, if we may, say of all the other species. It's going to be stronger than other species, and hence it's going to be the one that will survive. This will be the survival of the fittest of the mutations. To think of it like this, think of it as a bacteria. Bacteria, if anybody learned biology, there is, there's no like mama bacteria and papa bacteria and they fell in love and they had children together. That's not how it works in the reproduction organs of bacteria. Rather, how does bacteria work? Bacteria works in a sense that they could make a copy of themselves. Imagine you can do that, right? Imagine you could just like concentrate really hard. I'm not saying that bacteria is concentrate, but imagine you could concentrate really hard and then like duplicate an exact replica of you. It'll be great. Send them to do shopping, send them to class, send them to do this, send them to do everything. Bacteria can do that. Bacteria can go and replicate an exact carbon copy of themselves. Now, and I'm just using a random number, I'm not saying this is anything scientific, say out of every 1 million doubling of this multiplying of the bacteria, a mutation can occur. It's built in. Mutations can occur. So say there's 1 out of every 1 million mutations. Most mutations are harmful for the bacteria, for the body. Mutations are not good. But out of every 1 million, there's 1 mutation. Out of every, say, 1 million mutations, there's one that happens to be beneficial. Randomly, I hate that word random, but randomly it's beneficial. So this is something very interesting. You have something. And let's think of a bacteria on a dish. Now you have this bacteria over here. It has it has everything it needs to survive and to thrive. Say every 10 minutes it doubles itself. It can clone itself. It can copy itself. It can replicate itself. Now, every 20 minutes it keeps on getting bigger and bigger and bigger. Now say you take a nice bottle of antibiotics and pour it all over the bacteria. What's going to happen to the bacteria? It's going to die out. But say 1 out of those millions bacteria, or how much ever bacteria is there, one of them had a mutation, and that mutation sort of kung fu'd that antibiotics out of outside, and be like, not today, mister. Right? You are not coming in here today, and it just put the bacteria out. I know some terms though. Right? So they just put the bacteria right out. So now what's going to happen? All the bacteria in the dish is going to die out, except for one. Except for this one lone bacteria is going to stand over there, and it's going to be in its own. Now, what's going to happen? This bacteria is going to replicate and replicate and replicate. It's going to take over the entire dish. So we see over here, this is the idea of mutation, and this is also something called natural selection. The strongest will survive. Now, this is actually something that we do see. We know that there's there's bacteria infections in the body that resist antibiotics. Some of them would be, for example, methicillin-resistant Staphylococcus aureus. This, antibiotics does not work. You have also vancomycin-resistant Enterococcus. You have bacteria that do not respond to antibiotics. How did this happen? Through these random mutations, it's going to go and be able to build a defense against that antibiotic. So this we see can happen. This is something that is noted in the evolution terms as microevolution. Now, microevolution, we know it exists. Let's look at something else. Let's look at something called macroevolution. Macroevolution. Let's look, for example, at whales. Whales are, contrary to popular belief, if you just look at whales, you'll think of it, it's a large fish. If you don't know anything about science, and you came up a boat, right, and you're like, oh yeah, it's a very big fish. Whales are known as mammals. Now, why are they known as mammals? For a few reasons. Number one, they actually give birth to live young. They also have fur. Not a lot, but they have fur. They also breathe air. They have lungs. And they can also provide milk for the young. They are known as mammals. Now, as mammals originated on the ground. I mean, obviously, everybody, according to evolution, originated in the ocean, in the water. But mammals came from the ground, and then the whales went back to the ocean. Now, the question is, how and why did they get there? So, the why is, they say it's a pretty simple, answer, is because there was more food in the ocean. And there was too much, they were fighting too much in the land. They saw more food in the ocean, so they made their way to the oceans to get more food. This is interesting because this is the same reason why you have the species in the water, they went on the land for more food. Right? So, I guess a balance of the world. So now the question is, how did whales become sea creatures? If they were mammals, how did they get into the sea creatures? So, there's something called evolution, through random mutations. You have a mammal. We are known as mammals. Where are our noses, our mouths? Over here, in the front, in our face, right over here. A whale, where does it breathe from? It has something called a blowhole. It's more in the back. If this was a mammal, how did that ear blowhorn, how did it come from here, from the face? How did it travel all the way to the back? Science has an answer for everything. Very simple. It was through random mutations. See, what happened was, one time they had a baby, and the baby came out with the nose slightly too high. And they were like, this baby looks funny. Let's, put him on the side. But this baby was actually stronger for survival. Why? Because when he was going to get food in the ocean, in the water, it was easier for him to breathe because all he had to go was a little bit less higher than everybody else. So this baby became stronger, became the survival of the fittest, became the natural selection, and this baby ended up becoming more productive and formed more children than anybody else. More in the survival aspect of it. So you have this, and then what happened is that this offspring, count a few million years or how much ever you want, a few 100,000 years, and the nose slowly kept on climbing. And it kept on climbing until it was right where it is positioned now. And Shalom Al Yisrael, and this is how we have the whale that we have today. So this is something very interesting. This is, by the way, not even macroevolution to the extent. This is similar to just an idea of just a change of the actual species in itself. Let's think of macromutations means one change happened to another, a change on a large scale. How does that happen according to science? So let us explain something like this. You have two different types of dogs. The example that I saw when I read this, they have, and I don't know dogs, but I'll give you the example. There was a Saint Bernard. From my understanding, it's a very large dog, and then you have a Chihuahua. That I know, it's a little dog you put in your purse, right? And you carry around. That's the one. That's the one, right? That's the one you put in your purse, right? Okay. So you have these two dogs. Can they interbreed? It's going to be very difficult, but maybe through artificial insemination, they can interbreed. I mean, the puppy's going to look very interesting, but they can technically have puppies. They'll be weird puppies, but they'll have puppies. Now, imagine you take these two dogs, these two species, and you put them on separate islands for millions of years. Now what's going to happen is that the St. Bernards are going to go through some random mutations through the time, to the extent that they'll eventually, through interbreeding and through other mutations, they'll actually become a little bit, at least, of a different species. And the same thing with the Chihuahuas. The Chihuahuas will come into a different species and they'll become something else. So, after all these mutations take effect, if you try to interbreed them now, they're not going to work. Why? Because they're two different species. That is macroevolution. That is the evolution. That is the evolution idea in very, very brief. So now let's try to understand some holes in the theory, some problems that we have in the theory. Now, from my understanding, when they teach evolution, and I may be wrong, I know in some places they do teach problems with evolution, but for the majority of places, if you're going in high school, especially in a public high school or for anything, they don't really teach you the issues and the problems that they have with evolution. So let's speak first about the evolutions of mammals. So just so you know, mammals, humans are mammals, dogs are mammals, bats, whales, elephants, giraffe, panda bears, all mammals. You can see there's a little bit of discrepancy between a bat and a whale. Right, there's a little difference. Right, it's called a few hundred feet in size and a few, I don't know how much tons, in size as well. Yet we all came from a same ancestor according to evolution. So the problem that we have over here is a problem called the speed problem. The speed problem is according to Carl Sagan, he said something like this: a characteristic period for emergence of one advanced species from another is perhaps 100,000 years. Now, say there's a big machloket in the poskim of the evolution of where and when the mammals began and how you have different wide ranges. Say we use a middle ground of 65 million years, which means 65 million years ago, according to evolution, there was a sort of a mammal that was the first type of mammal, and from there came everything else. Now that means if you take 100,000 years from which each advanced species can develop to another advanced species, how many do you have in 65 million years? You have 650 periods of 100,000 years. Does that make sense? Is that clear? If you take 65 million, you divide it by 100,000, you get 650. Which means and maybe you'll understand it like this, we have 650 ticks to get from a dog to an elephant, and in transition period. The problem that we have with this is that, let's use an elephant's, the elephant's trunk. It has 150,000 muscles. So somehow, in 650 times, this dog's snout had to turn into an elephant, which is very unlikely, even if everything is perfect. And you look from everything. You look from a dog to an elephant, from a dog to a bat, from a whale to a dog. All these things which all came from one species is very hard to grasp in that period of time. It's just even 65 million years through random mutations is very difficult to understand. You look at it from a different perspective. According to evolution, the humans, we evolved from a species called Homo erectus. This Homo erectus appeared on Earth about 2 million years ago, according to science. Now, you look at the skull of this Homo erectus, its brain size was roughly half the size of our brain size today. Our brain size today is about 1,500 cubic centimeters. Theirs were about between 800 to 900 cubic centimeters, which means that it had to double in size. But double in size not just means that you just double in size. There's neurons in there. We have about 100 billion neurons in our brains, which means half the size, half the neurons, 50 billion neurons. So in 2 million years, you have to go from 50 billion neurons to, anybody with me? 100 billion. No one's with me. Like nobody. Okay, nobody? Okay. Okay.
I'm trying to understand so hard.
Okay. We'll take it slow.
It's a lot of math, Yeah.
We are, okay, fine. Well, it's very, very simple. It really is straightforward. Let's speak specifically about the neurons. We had 2 million years ago, according to science, we had roughly about 50 billion neurons. Forget about what the word neurons means. Forget about what it means. Just think about the number 50 billion. Now, we have 100 billion neurons, whatever that means, right? Let's forget about that, what that actually means. So now, just to try to simplify it, whenever someone's teaching something, whatever, yeah, but I'm saying, let's make it very simple for our American population. And not you. I'm talking about it, on camera. People. Chas v'shalom, not on camera. All right. I dug myself into a hole that I can't get out, so we're just going to leave the hole and we're going to dig another hole probably soon. Now, if you have, remember 50 billion to 100 billion, right? That number is a pretty significant number, and you have 2 million years to fill that gap. Now say that this Homo erectus, which is the old humans, the prior humans, say they can breed every 10 years. A very, very liberal number. Very, unlikely and, problematic, but let's say every 10 years. So if you take 10 in 10 years, how many generations do you have in 2 million years? You don't worry, you don't have to do the math. I'll tell you, you have 200,000 generations. 200,000 generations. So which means is, in 200,000 generations, you have to go from 50 billion to 100 billion neurons. Now, in order for that to happen, that would mean, there's a few possibilities that you can go here, but just very simple, every generation will have to add 250,000 neurons. Now, this is very problematic because we have every generation today, and we see that every child born is not producing another 250,000 neurons. So this answer is very unlikely. But then you could divvy up the math in any way. You could say one time it just happened to be that there was an increase of 2.5 billion neurons. I mean, any way that you break this math does not make sense. It just doesn't make sense that the time period that you're giving me from when this was this size to when this was supposed to be this size, it just doesn't make sense. It's mathematically speaking, it's very improbable. Possible, yeah, but not improbable. So now, that is one issue we have. One issue we have with evolution is that the time frame that they're giving is very unlikely for it to happen. Because you have to understand, the way that evolution understands it is that we all came from like one bacteria, one like organism. There's one organism that came into the world, and everything else from that came into being. Where did that one organism come from? We'll deal with that soon. When soon? Right now. So now, the question is that we had something called inanimate objects. With inanimate objects are objects that are not alive. This, the Big Bang, which we spoke about last week, you have these, rocks are inanimate. Earth, inanimate. Things that are not alive are inanimate.
Like tables? Yeah.
Everything in existence by the Big Bang was inanimate. Why? Because it was not possible, according to the Big Bang, to have any any animate object. So somehow, from inanimate, we came animate, which means that somehow there was a first live cell. So, and the question is, where did the cell come from? Where did the original life, let me explain like this. In order to have evolution, life has to exist. Life has to exist before you can start saying it diversified. Before it started mutating, it had to exist. Where did it come from? And the answer is, I don't know. I don't know.
Evolution?
So evolution doesn't have an answer to this. In order, and they don't have an answer for this. Yeah. And so they scratch your heads. In order, well, there's some answers, and it's these answers are humorous. They're enjoyable. We're going to B'ezrat Hashem get to that. So, in order to understand what a living cell is, in order to understand what it means is it has to have a few criteria. Number one, it has to have a cell wall. Number two, some of you probably feel like you're back in microbiology. But number two is that the cell has to have the ability to maintain and expand that cell wall, which means it has to have the ability to grow. Number three, it has to have the ability to process food. And the food has to be in the nearby area. Thank you very much. It also has to have the ability to split, which means to reproduce itself. All these things classify it as live. If it doesn't have this information, it's not live. The question is, where did the first cell come from? Remember we had a question last class about the Big Bang? Where did the matter come from? Now we have a different question. Where did the first live cell come from? Good question.
Do they know they have this question?
Yes, they do know they have this question.
Do they have an answer?
They do not have an answer.
And they still believe in it?
They still believe in it. Ani ma'amin be'emunah shlema be'evolution. Lahavdil alef ve'elef adalas. Yeah. They do. So, what?
That's why it's a theory.
But they teach it
that's true if they would teach it like that. So we have here two things. It's a great thing that you picked that up. Microevolution and macroevolution. Now that we had a little bit of basic understanding of evolution, now we can classify things. Microevolution is what we spoke about earlier. You have bacteria that mutate, can build a defense against antibiotics. We got that. That exists. We know it's proven. Chazaku ba'uch, we can move on. That is fine. That is, you could say that is a fact. Microevolution. Macroevolution is where we have the problem. How can you tell me that one species turned into another? We don't have evidence for that. Where did the first species come from? Where did the first live species come from? We don't have that. We don't have that evidence. We don't have that. Science does not have an answer for that. We have a few problems for that. And in fact, Darwin himself said like this. He says, and I quote, "The eye to this day gives me a cold shudder." The eye is such a perfect specimen that to happen by accident is very it's very hard to understand according to that. So let's move on with some problems that we have with evolution. And by the way, I'm not saying that evolution is not true. and because I know there's some die-hard evolution fans out there, I'm not saying that it's not true. Right now I'm saying based off science. I'm not going, we didn't even touch the Torah yet. We didn't even touch the Torah's view yet. We're talking based off science, and this is based off, and this is not things that I decided to come out. This is like, these are questions that are brought by people that are in these fields. Let's look at a third problem that we have with science. There's something called fossils. So, to understand what fossils are preserved remains of a plant or an animal's body. Now, how could these preserved remains come? It could come in one of two forms. Either it could be an actual imprint, so you don't see anything, you just see like a footprint of like a Tyrannosaurus Rex, whatever it is that you see. You see that imprint, or you could actually see a preserved part of it, the skeletons, the bones, that. Whether it's true or not, a totally different topic, totally different thing to understand. But the way that they understand it is something very simple. You have, you're baking a 7-layer cake. As a baker, a chef, well, actually, you don't have to be a baker or chef. As any normal human being, you know that the bottom has to come before the top. And then the second layer has to come before the third, and so on and so forth. Which means is, according to the fossil records, the lowest level had to come first in time. And then as you go higher, means that it has to come higher in time. Makes sense? Very simple. Okay. So, when we're looking at fossil records, according to evolution, we should see nearly identical parent species, which means is, if everything evolved from one sort of species, we should see something, like transition, basically, transitioning. We should see something that transitions between a human and an ape or a chimpanzee. We should see something that transitions between a reptile and whatever they say that comes after a reptile. Like stages, sort of stages, here's a good example. Where do wings come from? You want to say wings come from the fins? Where we should see, or did the wings come? We should see a transition period, and this is something very interesting because we should technically see underdeveloped wings in the fossil records. And by the way, we'll soon speak about the fossil record. We have a lot of fossil records, so we should see like a sort of half wing, creature, or even a full-wing creature, but not fully functional, because we'll soon see when we speak about birds, there's a lot of factors that have to come to flight. You can't just have a wing. As you ask many people that try drugs and they try flying, it doesn't work if you paint, a kite onto your hands, and you try flapping very fast. It's just not going to work. So, the idea that this brings up into question is something called survival of the fittest. Let's say you have one little duckling. And this little duckling does not have any wings. It can run very nice and fast. Then you have another duckling. Let's call this duckling the ugly duckling. Why? Because it has extra things on the side. It's sort of flapping. Now, which one will be able to run faster away from its predators? The one without the extra, situation flapping in the, on the sides. I'd be like, what's going on over here? Why do I have these little things over here? Now, survival of the fittest would mean that anything that's underdeveloped shouldn't come into fruition, shouldn't come into the natural selection, shouldn't come into the being. It should stop right then and there. You have somebody that's running away and it's a half wing, is not going to be as fit to survive as somebody with no half wing. It's imagine trying to run away from a robber, let's say, that is, while carrying, 3 extra, pounds. It's much easier to ditch the pounds and run. You'll be able to run faster. So this is also a problem that we have. Now, when you're dealing with fossil records, Professor Herbert Nilsson of Lund University in Sweden disclosed, and this is back in 1954, that the fossil material is now so complete that the lack of transitional series cannot be explained by the scarcity of the material. So where is it? We don't have the evidence. You're telling me about evolution. You're telling me about this. Show me the evidence. There is no evidence in it. 1974, paleontologist Barbara Stahl said about bird feathers, how they arose initially, presumably from reptile scales, defies analysis. They can't explain it. It doesn't make sense according to science. For me, obviously it doesn't make sense. But according to science, they say it doesn't make sense. You have, and then this is something very interesting, and I'll read it for you. People who believe in evolution must either close their eyes to the existence of these flaws and these questions, or have faith, emunah, bitachon, in that someday these difficulties will be, by such issues will be answered by science in the future. You could have emunah. I personally don't have that much faith in it. Now, I'm not saying that it's wrong. I'm just saying scientifically standing with the evidence that we have right now, possible, maybe, but not probable. Let's look at something else. Another problem, another flaw with evolution. So Darwin assumed that the species could slowly evolve through a series of mutations. So, there was, scientists that decided to see how they can mutate these species. Let's try to mutate these species and see if we can actually change it. So there was a scientist by the name of Ernest Mayr, from Harvard University, a geneticist. In 1948, he had a theory called genetic homeostasis. And he did a test that performed on fruit flies. What he did is that this fly naturally grows 36 bristles. Now, what he tried to do is he tried to manipulate that. And he was able to manipulate to bring this fly down to 26 bristles and as many as 56 bristles from the normal 36, right? So minus 10 plus 20. Now, what happens when he pushed the fly genetics beyond these limits? They died out. They became sterile and they died out. Which means is that he was able to change them, to mutate them to a certain extent before they died out. Now, let's say he got the extent. Let's say he got a bunch of, 26 bristle flies. They're like hanging out, be like, hey, what's up? He's like, what are you? I'm like, I'm 27 bristles. I'm 26 bristles. What's up? He's like, don't come to my part of the hood. So let's say the 26 bristles, group, they hung out with each other and they interbred. And what's something very interesting happened? That after 5 generations, they all came back to 36 bristles. Which means is that the mutations sort of fix themselves. They sort of return to normal. It's like, like you're driving and, you have the GPS and the GPS saying, make a right turn in 400 feet. And you're like, oh man, I just missed it. What do they tell you after that? Recalculating route. And they keep on, no matter how far you go, they keep on, in the most calmest way. You could be so far off, they'll just be like, recalculating route. So there's a certain amount of time that after these flies came out as 26, 27, 30, doesn't matter the number, less than 36, they sort of recalculated the route and they sort of corrected themselves. We have a very big problem over here. Because over here we see that the genes do not have the mutability limits that we thought that they did. If we pushed them, they died. If we went under, they actually just changed themselves. And this went on again with, they created eyeless flies. They were able to create flies without eyes, right? If flies are not, scary enough for some, I know for some people, they're like, I don't understand, there's some things like squirrels, cats, not a problem. A fly, forget it. You see somebody in the street, just it looks like they're doing kung fu in the air, and, it's like, I don't know, bee or, a fly, chas v'shalom, something, God forbid, that's going close to their vicinity. It's something very interesting, but, it is more particular to certain gender species, which we won't want to point any fingers. But cockroaches have a huge problem. Ants, not so bad. No, ants not so bad. Cockroach, no. What is it? One too many feet? I don't know what. I haven't dealt with the science behind it. It's a. So if it would be a pretty cockroach, it would be something else.
I'll be okay with that.
So look at the beauty of God's creation. Imagine God would have created a cockroach to be very colorful like a butterfly. Be like, oh look, my dear husband, we have cockroaches. Isn't this wonderful? But no, God created the cockroach to be. There must be, yeah. Yeah, right? Yeah. Must be something.
Learning.
Exactly, it's innate, right? You see a mouse, what do? You jump on the table. And that's it. Even though you're 1,000 times bigger than it. I scream and then jump, right? So, in any case, we see something very interesting over here. We see something very interesting from this test, is that no matter how much mutations you made, they sort of returned to the original thing. And not only that, they were actually harmful for the species. So it puts a little bit of a dent in this evolution theory. Now let's speak a little bit about mathematics. Here's where it gets interesting. You'll enjoy it. I'll make it very simple. So,
Grade level, right?
yeah. So, and I'm going to use an analogy. We're going to start with an analogy with Rabbi Dr. David Gottlieb. Say I take an object and I paint one side red, and I throw it up 3 times, and every single time it lands on the red side. Now, if I ask you, do you believe that it's probable, very likely that happened? You might say yes. I see a bunch of you shaking yes. Really, you should not. You should not be shaking your heads yes. Why not? Because I didn't tell you how many sides it has. You thought originally when I said that it had 2 sides, like a coin. Now, if I take a coin 3 times and I flip it up and I say his head, all 3 times, the probability is 1/8. Very likely, very possible, not something. But let's say I tell you that this object that I have has 500 sides, 1,000 sides. Now if I ask you the same question, I took this object, 500 sides, I painted one side red, I threw it up 3 times, it landed every single time in the red. Would you believe me? Maybe, but less likely. I have a little bit doubts about your, throwing abilities. If you, every single time it landed on the red. Now, what happens if I ask you the questions? I threw an object, I painted one side red, and it landed on the red side every time. And you ask me, well, how many sides does it have? And I tell you, I'm not telling. And then I say, do you believe me? I'll say, I don't have enough information. You have to tell me how many sides. And then I can base off the probability if it's likely or if it's not. This is what evolution is. You ask evolution, what is the probability of it happening? You got to know. You're coming with a theory. I want to know what's the chances of it happening. Evolution will tell you, oh, yeah. I know what it is, Got some snack? They don't know what the probability is. And rightfully so they don't know, because how are they supposed to know what are the chances of things happening in the Ice Age and the Tropical Age? There's so many different factors that come into play, there's no way that they will be able to know it. So let's speak a little bit about numbers, about probability, about the beauty of mathematics. Math, if you understand it, it's really beautiful, how everything works. Most people hate it, which is understandable, because if you don't understand something, you already grow to dislike it, which it makes sense. There is, let's explain very simple. In 1981, a Nobel Prize winner by the name of Fred Hoyle said that the odds of a single bacteria evolving randomly is very unlikely. How unlikely? It is more unlikely that you have a tornado that goes through a junkyard and assembles a Boeing 747 jet from the material inside. Now, I'm not just saying that it looks like a Boeing 747, I'm saying every single detail. With the screens in the front, that you could, whatever, I don't know how size the screens are in the planes now, at 8 inches, with the touchscreen, everything with the seats, economy, so you have 0 feet, so you could hear and feel the breathing of the person in front of you and behind of you. I'm talking about the whole scenario. That there's more of a chance of you have a tornado going through a junkyard and building a 747 from it than having a single bacteria, just one bacteria evolving, and it just happened to have. So I want to take you through a little bit of a journey. This is Rabbi Lawrence Kellerman, brought it down.
How did they come up with that odds? How did they come up with that probability of a tornado?
So it's very simple, because they look at the statistical ability of it happening versus statistical ability that it's happening. So you could change, based on math, you could see how many parts it has, how many things it has to get together. There's so many different aspects of it that the point of this being is that it's so unlikely. This is how unlikely it is. It's more likely that this would happen, that this tornado will go through a junkyard and it will build you a 747. So let me share with you something from Rabbi Lawrence Kellerman. The maximum amount the universe existed, not according to the science thing, right? You're talking about billions and billions of years. How many seconds is that? It's a lot. It's a lot of seconds. Every single day has 86,400 seconds. That's a lot of seconds. Yeah, think about how much time you waste watching a movie or watching a TV show. Think about how much seconds you're like, oh my gosh. And sometimes, after watching this wasteful time of time, you'll be like, oh my God, I can't believe I just wasted 2 hours of that. Think about how many seconds that is. 2 hours is a small number. Seconds is a very large number. So, how many seconds are in the billions and billions of years in the universe created? A very large number. You would agree, right? The number is, we're going to condense it in mathematical terms, 10 to the power of 18. It sounds small, but it's obviously large. It's a very large number. So that means to say that 10 to the 18th is a very, very large number. Think about all the seconds in the billions and billions of years. Okay. The probability of an enzyme developing accidentally is 10 to the power of 20. 1 in 10 to the power of 20. Which means, I don't even have to explain. I think that's pretty self-explanatory how big of a number the probability is. What about, let's say you take a few thousand enzymes, because we have thousands upon thousands of enzymes in our body. Let's say you take 25,000 enzymes. The probability that we have more than that, 25,000 enzymes in our body. What is the probability of that happening? So the probability of it happening spontaneously once in a billion years is 1 in 10 to the power of 599,950. Close to 6 to the power, which is a number that we can't even fathom to understand. Let me explain to you how large this number is. This you will probably enjoy. A forest that is 1 million square miles. Now you'll say, okay, how big is 1 million square miles? Good thing you asked me, because I'll tell you. Okay, Israel is 8,500 square miles. That's a very large. Azerbaijan, I made sure specifically to look at Azerbaijan. Azerbaijan is 33,400 square miles. All of Azerbaijan, all of it, is almost 33,500 miles. So which means is when I'm saying 1 million square miles, it's a very large amount. If anybody not from Azerbaijan, you look at India. India is 1.24 million square miles.
Not from India.
USA, I'm trying over here. Right, China, should we try China? China is 3.7 million square miles. USA is 3.8 million square miles. So Russia is actually very large, it's 6.6. So, all right, we'll leave this for, we're going off topic.
Jewish geography.
Oh, no, how many square miles? That's a good question. So, if you look at 3.8, let's use America, right? The US of A, right? We have America. You have 3.8 million square miles. You take 1 million square miles. It's a very large chunk of USA. So you take that and you fill it up with trees, all trees. How many trees? Good thing you asked. It's 10,000 trees per square mile. That's a lot of trees in all the miles. Now, if I were to ask you how many leaves per tree, also a good thing you asked, it's 100,000 leaves per tree. Now, if I were to ask you how many leaves are in all this million square miles, you will tell me it's a very large number. You want to know the number? The number is roughly 10 to the power of 15. That means that 10 to the power of 15 is a tremendous amount of number, which means is everything that I told you till now is just should be mind-boggling of someone coming to tell you, be like, this probably happened. Oh yeah, what's the chances of it happening? Oh yeah, very, very, very unlikely. And if I take 10 to the power of 15 varies, is how much I have to put in that vary, in between those varies. So, the idea of a variable bacterium developing by itself is 1 in 10 to the power of 39,950. Let's speak for a second about what's the probability of a human being being created. Right, we're humans, we hope, right? So we're here. What is the probability of us being here spontaneously, randomly, whatever word you want to use? It is 10 to the power of 1.25 trillion. That should just be like, and people are like, yep, we came from nothing. This is what science says. Not really. If you look at it doesn't make any sense. It doesn't make any sense. So if you were to write 10 to the power of 1.25 trillion, you know how many books you would need? So I wanted to try to make you understand this number. So I tried to figure out, like, what's a book or a series of books that everyone knows and is very large. So I thought about Harry Potter. Very good. Zakabul. Okay. So how many words are written in all the Harry Potter books? How many words are all? Oh, you're asking. I thought you know. I thought some of the people. I met somebody once that told me he has Harry Potter books in his bathroom. So I said, why? I said this. I mentioned this before. So a while ago, I could mention it again. It's a joke, so I guess I can mention it if it's been a year. So he's not for toilet paper. No, he says because he likes reviewing it every so often. And I'm like, who's testing you on Harry Potter that you need to know it? Like, I don't understand. People that Harry Potter is like, there's a Bible and then Harry Potter. So I don't know how many books are in Harry Potter. There's like 7, 8, 9. I don't care. 7. Okay. So there's 7 books. How many words are in all the Harry Potter books? A little bit over 1 million. You want the exact number? I had to do this research. I wasn't going to sit there and count. So I thought, I'm like, what is going to be something that somebody would count? I thought Harry Potter. Harry Potter would be a good thing. So I was right. I searched for it and I found it out. The number of words in Harry Potter is 1,084,170 words. That's a lot of words in all that book. To write 10 to the power of 1.25 trillion, you will need several 100,000 books just to write the number down. Just to write the number down, you would need so many books. And yeah, this is where we came from. I don't know. I have a question, Professor. Doesn't make sense to me. It's a big problem. Yeah.
I don't get that. This number is the probability of us, what? Coming from?
Spontaneously through, yeah.
That's what evolution
Yeah.
is.
Evolution is, came in from, first it came a little bacteria, and then bacteria came, and then became a little, a fish, and then a fish became a little reptile, and the reptile became a little, mammal, and the mammal became a little, bigger. Why is this believed? It's a good question. But it's believed. With such, oh my gosh, if you read what people, they're like, no, like, oh my, people believe it, they're willing to go so far with this, such a strong belief they have for evolution.
Are all those zeros?
Yes, they are. Okay. In 1991, Scientific American staff writer quoted Crick saying the origin of life appears to be almost a miracle. And I agree with that. So, you look at birds, for example. Birds, the bones of birds are very different than the bones of any other animal. The bones of birds have to be, they have to be hollow. They have to be, well, they're not, they're basically hollow, but why? Because they have to be able to allow for flight of the birds, but they have to be strong enough for the birds. Now the question is, how is it possible that a bird could flap its wings several times a second and fly for hours without getting tired? You have people that just walk up the stairs and they're coming into the room like, they're like, did you just run a marathon? It's like, you saw how many stairs they are? You know how steep they are? They're like 6 inches higher than the regular stairs. But let's say even if you have a marathon runner, like someone who's able to run, how much can he run already before they get tired out? There's going to be a time limit where they can be like, you know what, I can't. There's so much that I can do. Now, why is it? Why can birds fly for so long without getting tired out, and humans or anything else cannot? So the answer is something called oxygen. When we exercise, yeah, you can put a bunch of birds' words together. When we exercise, we need an increase of oxygen. The problem is we can only get so much oxygen. When we breathe in oxygen, we get the oxygen. When we breathe out oxygen, we're breathing out deoxygenated air. We're not able to bring in that oxygen. So our muscles get tired because we're not getting the continuous flow of oxygen. There's something very miraculous or evolutionary, if I could say, for the evolutionists, that happens for birds. There's something very interesting. Birds, when they inhale oxygen, half of the oxygen goes into the lungs, and the other half goes into a special reserve of air sacs that the birds have. Now, when the birds exhale the deoxygenated air, those air sacs go and they give the muscles a continuous flow of oxygen, which means is that the birds have a continuous flow of oxygen no matter how many times. So this is why they're able to fly for hours on end. They're able to migrate. Who told them how to migrate? Different question. I don't know also. Well, technically I do know, but science, it's a good question. So you have something else. You have like birds, bats, insects, all have wings, but they're all different. You have fish, whales, both have fins, but they're both different. What are the chances of that happening? Two different species suddenly having the most random mutation together. That's imagining like you have two people from different origins, from different countries, from different upbringings, from different social backgrounds, from different everything, that write the same exact book verbatim, word for word. What are the chances of that happening? Very, very unlikely. Possible, again, but very unlikely. So, desperate times calls for desperate measures. And you have here a person by the name of Sir Francis Crick. He was a biologist. He was the one who deduced the double helical structure of the DNA. He actually received the Nobel Prize for this. So he was bothered by a very big question. Where did the origin of life come from? How did we get the first bacteria, the first cell? Where do we get the first live cell? In 1983, Crick wrote a book called Life Itself. And in it, he said a very interesting theory. The theory is like this. You're familiar with extraterrestrial life? Okay, so he's also very strong of this theory. He says, how life came to this world? So we had this extraterrestrial life, so aliens, basically, right? Aliens living on different planets. They were nervous about the fear of extinction in their planet, so they shot out into space, like their frozen seed into space. So, to sort of seed other planets, like bacteria and that. So and what happens is, it just so happened to be that Earth, it received it. Gravity came and pulled it in, and it came over here, and poof, So we are all part of, this alienistic culture. The problem, it seems like a nice theory, but there's an issue. The issue is, where did they come from? Exactly. Where did the aliens come from? Oh, from a different planet. So if you go back time enough, there has to be an origin. Where did that origin, come from? Let's deal with some, So from here on point, it seems very clear where we're leaning, towards. Now, again, I'm not saying evolution is false. There's part of evolution that's very true. There's other part of evolution that is, according to science, does not make sense. With all due respect to all the scientists that they spend so much time on this, it just doesn't make sense. The numbers don't match up. We're missing evidence. That'll be all nice and dandy until we encounter something called fraud. So there is, we've had some major issues. So like we said with the rock strata, like fossil records. So you have the lower it is, that the more that it was supposed to be prehistoric, that it should have came beforehand. Now, they found in fossil records, I can't say creations, but animals, species that should have existed before fossils that they found in the higher realms. Which means when they went into the fossil digging, they found things that didn't seem to add up. some of the things should have been higher up in the strata, other things should have been lower up in the strata. Which means is that there's some animals that they thought should have existed after, really existed way before. There was a, in the beginning of the 20th century, the early 1900s. In fact, I'll give you the date. Why not? August 31st, 1909. You had a person, a paleontologist by the name of Charles Doolittle Walcott. He was researching the Canadian Rocky Mountains that were full of fossils. And he was also served as the secretary of the famous Smithsonian Institute of Washington. And he found a great discovery. He found the oldest fossil ranging over 500 million years old. Crazy. The crazy amount of stuff with it. But during this time, according to science, 500 million years ago, 500 million years ago, the Earth was dominated by water, and life has not yet crawled out of the sea. Now, he found something very interesting. And by the way, these fossils that he found were extraordinarily well preserved, to the extent that it wasn't just the hard shells, but rather it was the molded, it was even the soft parts of the anatomy. I'll tell you where, before I even go for that, I'll tell you where I got this. Before I gave this class about 2 hours ago, I get a phone call from Rabbi Finger, and we were talking about certain ideas, and then, I asked him, if I didn't get a hold of, he has a book, which is called, what? He's called Search Judaism. Oh. Yeah. He wrote a book. He wrote a book. Yeah, he wrote many books called Search Judaism. So he, was kind enough to send me, and I found some very, very interesting information on it. And I want to, so I have to, this is part of it, his works. I want to, give credit where credit is due. It's something very, very interesting. So I had this information before, but I found more information over, here now, Baruch Hashem. So he said like this. He said that these fossils, they sat there from, according to science, 500 million years ago until 1909 when paleontologist Charles Walcott came on to this. Now, how much did he find? How many fossils did he find? A tremendous amount. That every year, every summer, he would come back and he would collect more and more fossils, to the extent that afterwards contained 65,000 fossils that he found over there. And of all the fossils, it was over 170 species of different species that he found. Now this caused a very big problem because 500 million years ago there shouldn't have been 170 species. This shouldn't have happened. This was a very big problem because he was also a very avid evolutionist. So he did the only logical thing to do is he hid those fossils. He didn't bring them out, and he hid them in the Smithsonian. Okay. When was this discovered? This was discovered in 1985. This is when it was discovered. In 1989. Harvard paleontologist by the name of Stephen Jay Gould, he wrote a book called Wonderful Life. And in it, he argued that the presence of 170 widely varied species forces a fundamental change into the understanding of evolution. This doesn't make any sense, because there shouldn't have been that many. It shouldn't have been, especially on life. It does not make sense. It puts a very big hole in the evolution theory. So he said that rather, somehow, these diverse species emerged and evolved simultaneously. Somehow, it just happened to, to happen. A chaotic, and I'm quoting, a chaotic explosion of life. Very, very problematic, type of situation. Now, look at what people who believe evolution, when they find the evidence, instead of sharing with it, they hide it. Now, you're believing somebody who's basically trying to sell you something. Now, it's becoming a business deal almost. You go to, someone who's selling you a product. Let's say you go to somebody they're trying to, sell you some cream. It may rhyme with shed sea scrolls, right? Or, something along that region. And they say, listen, hey, you're very ugly, come over here. You put this cream, you make yourself beautiful. And they come over here. They're trying to sell. Are they going to tell you, well, maybe there's a problem with this cream, maybe there's not? No, they're going to tell you all the good things about it. What happens if there's a scientific study that comes with a problem? And by the way, I'm not, the Dead Sea, it's beautiful, it's amazing, it's very healthy. I'm not chas v'shalom putting anything against it. There's no scientific evidence as far as I know that anything against it. But I'm using it as an example. You go over there and you say, there's a study that comes out that it's very bad for you. Are they going to put a slab on their little booth, be like, buy this, but by the way, general surgeon's warning, if you get this, you might, mutate to cigarettes. They do because they're required to by law. You think they want to do that? You think they were like, what's going to sell the product? If we slap a warning on it, be like, this might kill you. Be like, this is going to sell. Marketing at its best.
It might kill you. It's going to cause you to have lung cancer. It's going to cause your teeth to fall out.
Right. But they don't put all that information on there.
They also write it really small.
They put it really. Oh, they put it. But
Have you seen what those things say?
I don't smoke, so I don't know.
In Thailand, they had pictures.
Oh, they have pictures? That's very smart. That's very smart.
No, it's not.
That is smart for people that smoke. They should look at it.
It looks like
That's good. I think they should move that over here.
the guy from the Lord of the Rings.
So in any case, so now we're dealing with scientific fraud. All right, over here we have, now this is not scientific fraud yet. This is sort of just like withholding evidence. Well, let's go on. The British scientific community, they found, the paleontologists and the anthropologists, they discovered a skull of a hybrid human. Crazy discovery! A crazy discovery. They called this a Piltdown man. This is, they found this, the intermediate stage between man and ape, between human and ape. Crazy, unbelievable. Until 1954, when they discovered that somebody put together the bones of an ape and the bones of a human together. And they sort of presented it and they found it. Complete fraud that they discovered from it. So this is the type of, how much strong they believe in it. In July 1998, National Geographic, a very respectable magazine, they published an article, Dinosaurs Take Wings. So according to evolution, the way that the birds came into being, it came from there was a dinosaur transition to a bird. So they discovered something that filled the gaps, a sort of a primitive bird, but with teeth and tail of a small dinosaur. Sort of like that combined thing that plugs in all the information that we needed. Amazing discovery there was like just celebration for the evolutionists. It was like, partying everywhere they were going. It's unbelievable. Until a very short while afterwards, somebody by the name of Dr. Olson. He was by the way, this is brought down in the New York Times in, the skull. Remember I mentioned to you earlier about the skull. I want to tell you the source for that. It was brought in the New York Times, November 22nd, 1953. That's who brought down this story. Then we went on to the July 1998, so with this half bird, half dinosaur situation. Dr. Olson, a curator of birth of the Smithsonian, pronounce it right, okay, Institute of National Museum of Natural History, he immediately recognized that this is a problem. This is a scandal, this is a fraud, and he wrote an open letter dated November 1, 1999, and addressed to the Secretary of National Geographic. And I don't have to go through the letter, but it wasn't the letter about like, congratulations on your finding. It was, this is fraud, this is fake, this doesn't make any sense. So National Geographic had found itself in a very embarrassing situation. They had to retract this entire article, that the fossil was fake, and then a few months later, 7 months later, in October 2000 issue of National Geographic, they put a comprehensive article explaining how they came into that. What happened was, where did they get these fossils from? In a place in China, there was a place that farmers found it very beneficial and very financially pushing to sort of present fossils to people who want to buy. Now, people wanted to pay good money for the fossils, but people paid better money if it was a full fossil. So some of them doctored these fossils. They sort of used some glue, and they sort of, they decided to make it a full thing. So this, farmer, he glued together two completely different fossils, and he put it together and he presented them. And they went and they said, "Look, we found it already," without even doing any research on the idea of it. They went and they did it. Another piece of falsifying information. A person by the name of Ernest Haeckel. He made huge charts of embryos, and he showed that dog embryos and human embryos look exactly alike. Now, a short while after that, he was convicted of fraud by his own university. But it's something very interesting. To this day, they still teach this model. He was convicted by fraud, but they still are teaching this model. And maybe by now they changed it, but from my research on it, they're still teaching this model over here. So we come in with a lot of problems with evolution. We have problems that, microevolution, I give it to you, I agree with it, it's a fact, it exists, they can mutate a little bit. Mutation's fine. But macroevolution, we don't have evidence for that. To say that we came from monkeys, even though that's also factually incorrect, but let's say, most people don't know anything about evolution, they'll say we came from monkeys. So we say we came from monkeys, we came from all these things. Where do you have your proof to support that? Science is supposed to answer the questions, not bring more questions. Here, you're bringing me more questions. Where are your answers? I don't know. We'll wait and see. They're having faith that this is going to happen. Speaking about, monkeys and, and where they come from humans, we say that the scientists have sequenced the genes of the chimpanzee and found that they're 96% similar to the people. To the human being. It's a very, very close similarity. So, how do you answer that? So the question is, did we come from monkeys or did monkey come from us? So look at the Gemara in Sanhedrin, page 1098. It says like this. It says that the generation of the Tower of Babel, they were split into three categories. They were the people that built the tower, they wanted to fight against God. But then not all of them wanted to fight against God. One of them built a tower and they wanted to go and live there. whatever that means, where they wanted to live. They were punished. How were they punished? Hashem scattered them all over the world. There was another group of people who also built the same tower, but they had a different idea in mind. They wanted to go and wage war against God. God turned them into apes, spirits, and devils. The Gemara says that not that we came from the apes, but the apes came from us. There's also another thing that the section that they said that they wanted to go up and serve Avodah Zarah. God went and scattered their languages all over the place. With all these things, I do have to put another caveat into this class. Rav Shimshon Raphael Hirsch, he was personally skeptical about evolution. But 14 years after the publication of Darwin's Origin of Species, he came out, Rav Shimshon Raphael Hirsch, and he saw no theological problem with it, according to the Torah. He says it's very possible that you could interpret it. The understanding that we have of creation is very, very complex. We have very, very little information in the Torah that speaks about, in the Bible, that speaks about creation. How do you understand it? Is theoretical, actual? There's a lot of different interpretations of it. It's a very, very deep subject to understand. So it says it's not theological a problem thinking about that. Very unlikely, he doesn't believe in it, but it doesn't count as, this is a problem against the Torah, because technically you could say, in fact, he says that if science does ever prove that we came from one species, we would have to give even a greater reverence to God than ever before, because he was able to bring the entire existence all from one being. But even though still, it's very unlikely. We got to put that caveat in here. Let's finish off with a few ideas over here, and we'll open up for some questions. Good on time. Okay. I want to share with you a quote from a Nobel Prize winner in chemistry, Professor Harold Urey. He says like this: "Every scientist who investigates the origin of life discovers that the deeper we penetrate into the subject, the more we suspect that it is impossible that such complexity could have been the result of accidental evolution. Nonetheless, we have unanimously agreed as an article of faith that life on this planet evolved from inert matter, even though the complexity of life forms is such a great magnitude that it is difficult to imagine how it all happened." I have a different answer. The answer is that maybe there was another hand in play over here. Maybe there was another hand in play, and even if you want to go through evolution, there's one word that you have to take out, and that's random mutations. There's no way that this happened randomly. There's no way that this happened. Even with mutations, I find it very hard to believe according to the science that we have today. But even if you go through evolution, there's no way that this happened randomly, or all the possibility of a chance is so unlikely of it to happen that you can't. And people use this to push God. Just the opposite. When you study evolution and you see how unlikely it is for it to happen, this should lead you towards God. This should lead you to the fact that there has to be a divine supervision of everything that happens over here. It doesn't make any sense otherwise. Until science has an answer, this is the most probable solution. Possible, evolution. Probable, in my opinion, God. Imagine you go to evolutionists and you say you go into space and you find a car floating in space, or a spaceship, whatever it is, floating in space, and you ask them, where did this come from? What are they going to tell you? Someone created it, and somehow it got up there. Maybe out of all the billions and billions of explosions of stars and atoms, maybe it created this. What are the chances they're going to say somebody put it up there, or it just happened to, come through random explosions? They're going to say somebody had to create. Look at the cloth. Look at the cloth. Look at the stitching on the seats. It has to be that it was somebody created over there. Because Hashem, the next class we're going to speak about, we're going to deal with the beauty of the design. How you look at the world. When you look at the design of the world, you're going to think about, is this possible that there was just happened by chance? I know I said we're going to finish with that, but I have to finish with some other interesting facts, and we do have to deal. This was brought down by Dr. Nathan Aviezer. He's a physics professor at Bar Ilan University. The question is that, according to science, dinosaurs inhabited the earth. Where are they now? Why are they not here anymore? They were the most powerful beings on earth. How did they suddenly become extinct? In fact, this is the most famous mass extinction in the history of our planet. Where did they go? Beautiful answer. That was said by a Nobel Prize winner by the name of Louis Alvarez and his son Walter. He said like this: what happened was like this. It is a theory called the impact theory. There was a giant meteor that hit Earth. And it hit Earth at exactly the right impact. Not too strong, not too little, right? Like Goldilocks, right? Not too hot, not too cold. Exactly the right pressure that it killed all the dinosaurs, but all the mammals that were alive did not get affected by it. And that's why we don't have dinosaurs today, and we have mammals, and other beings, that we have today. So that is, his theory, which is interesting, to say the least. I do have to, bring up something that also Dr. Nathan, Abiezer brings down, the idea of probability. Now, let's say I go and I take a dollar bill, right? I take a dollar bill out, and I take this dollar bill, and I say, and I look at this dollar bill, and I'm like, wow, what is the probability that the serial number is E411044441F? It's like one in a, how many billions is that? Is a probability? Millions, whatever it is. It's crazy. Yet, here it is. Which means is that it happened. So it's not so, as crazy as you think. It might not be so rare. So there's a fault with this theory, with this just statement, is understanding what is probability. This was said not by me, but actually by a professor of the University of North Carolina. Let's look at a professor of genetics in the Hebrew University of Jerusalem. He said like this: religious scientists place a great emphasis on the remarkable coincidence which characterizes the universe. He says that that such remarkable events could not have occurred by chance, rather but had to be by a guiding hand. According to this logic, the probability, he says, of me writing what I'm writing right now on a dull yellow pencil using my left hand sitting on my kitchen table at the specific Jerusalem address is completely negligible. And yet these are all happening today and they mean nothing. So what they're trying to say is something very interesting. The earth came into existence. We came into existence. Now, we could say the probability, but yeah, we're here. Which means is that it had to be. As simple as me pulling out the dollar bill and me finding out the serial number just so happened to, be it. So I want to explain to you how Richard Feynman, also a Nobel Prize winner, how he explains probability. Now, you know what the probability of me pulling out this $1 bill and having out this exact serial number is? The probability is a whopping 100%. Why? Because I gave this number after I pulled it out. If I were to take out this dollar bill and I said, you know what this dollar bill is? This dollar bill is a serial number of E411, blah, 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 whatever it is else that I said. Right? If I were to say that and then I opened it up without looking at it and being like, wow, I got that. That is a rare occurrence. That is very, very rare. It reminds me, one time somebody says, you want to see a magic trick? I'm like, entertain me. Go ahead. This is years ago, as I was a little kid, but I still remember this vividly. So imagine this is a card. It's like, pick a card, any card. So I pick a card. Don't show it to me. Of course, yeah, we will know that. I see the card, and he looks at it. And he says, okay, now give me the card face down. I said, okay. I give him the card face down on the thing. He takes the card, and he does something like this. He takes the card, and he goes like this. He smacks it on his face, and then he starts, I don't want to rub a dirty dollar bill, but then he starts rubbing it all over his face, like this. And then as he's rubbing it, he's doing this, as if he, and then he says, was it the 7 of spades? I'm like, it was. Very good. That was really good. He's like, you see? That's exactly what you're telling me the probability is. Doing the magic trick and saying, think that you're faster than anybody else. They're like, I didn't see anything. It was a 7 of spades. That's the idea of what you're saying. When people say that, we already know that life exists, then the chance of life having to come into existence is 100%. No, it's not. You don't know how probability works. Probability work. Think of it as an example like this. You play the lottery and someone wins the lottery. Is that going to shock you? No. Let's say Tony won the lottery. Is that going to shock you that Tony won the lottery? No. Like, somebody had to win the lottery. Maybe it might be like, well, that's cool. I know this person. It might shock you a little bit more. But you knew somebody had to win the lottery. But let's say the next lottery, Tony wins again. I'm be like, that's going to be like, okay, that's going to shock you. Let's say the third time, Tony wins again. That's when you call in the fraud department and be like, hello. Yes. We came to investigate. Why? It's a rare occurrence. Rare occurrences happen all the time. And that's true. Rare occurrences do happen all the time. But consecutively, one after another, that's when it starts bringing you into question. Now I have a problem with this. Why did this rare occurrence happen all of a sudden, right after one after another? So, when you look at this, there's, it brings a lot of problems into consideration. The likelihood of this happening is very unlikely. To say that this happened, and it's problematic. It's very problematic when you deal with it. There's a lot to say about it, but it's getting late. And I want to open up for questions. People say that evolution is a fact. It's not a fact. Microevolution, you could say, is a fact. Macroevolution is a theory, and it's only a theory, and that's as far as it's going to go. There's many different things that you can speak about, vestigial organs, there's extra things, even though that all vestigial organs later are found to have a specific need. And we're not going to get into it because we don't have the time. There are many different aspects in these things, but I think the understanding is fairly clear. Is you can believe in evolution if you want to. No one can change your mind. You can decide whatever you want. But if you open your mind just a little bit, you have to see that there is another hand playing over here. There is something else that's guiding. That guiding hand is what we call God. As we call HaKadosh Baruch Hu, He is there and He's guiding every step of the way. It doesn't make any sense otherwise. When you look at science, when you look at the facts, when you look at the probability, it points to one direction, and a very, very obvious direction. Questions? Go ahead. Who's first?
Me.
Go ahead.
Okay, so for you're saying the winged creatures like that aren't functioning, so penguins, they can't actually fly, but they have wings. So is that a mutation?
Yeah. According to the evolution, of course, it's a mutation. It might be from fins, from a fish, but it's a mutation.
Also, carbon dating, isn't that technically off in the first place?
Carbon dating, well, maybe we'll speak about that when we speak about the age of the universe, probably in 2 classes.
You're saying, well, yeah, it's like millions of years old, but that's a whole machlokes in itself, but isn't the world like ish now?
So, well, that's all. We're going to speak about the age of the universe. I want to do a class on the age of the universe.
13.7, but we say like,
Yeah, we're going to speak about that. We're going to get into it. It's great. It's going to be a great class. What was your? Oh yeah, I'm sorry. You had a question about what is the problem? I don't think I'm going to have an answer to that question. What is the probability of
a guy or a girl turning into the other sex spontaneously?
What is the probability of a man or a woman turning into other gender? Nowadays and age, well, that's true. This day and age depends. You mean physically or psychologically?
Without a sex.
It's impossible. When we're talking about gender stuff, I don't want to get into it, but a man is a man and always will be a man, no matter what it associates with himself with. A woman is always going to be a woman, no matter what she associates himself.
What is it with those hermaphrodites? Are they a man or a woman?
Good question.
In the religious standpoint, how do they?
They're in the separate.
What do they do?
Right. So it's a good question. It's a difficult concept to understand. Yeah.
That are born with both.
Like a
What?
Any other non-gender related questions? Yeah. Not in the round table.
Earlier on in the class, Homo erectus.
Yeah.
And how the scientists think that Homo sapiens came from. Is that a real thing? Is they really found?
According to science, yeah, they believe that Homo erectus that was the origin of where humans came from now today.
So did they find fossils?
So they found the same fossils they found in the Neanderthals you were mentioning earlier. The fossils that they found, so what describes them as different beings? So they're a little stockier, they have longer. The fossil evidence also, you cannot. They sort of construct. Let me explain the mammoth. So the mammoth, when they originally found fossils for the mammoth, they saw the fossils and they constructed of what they thought it would be, and afterwards they actually found a fully, complete, fossil of a mammoth, like everything frozen in ice. So they were completely off with what they thought they said. So you have over here this like when they're saying how they think something looks like, does it actually look like that? We see that they were wrong, originally. They see these humans or the skulls that pure humans. Is it exactly what it is? Exactly what it is? I didn't study paleontology enough to understand the difference in it and how they arrived at their conclusion. But from my understanding is I am very skeptical, and not from a religious perspective, from a scientific perspective, to go and understand and what they say when they have have a history of a little bit manipulating with it. And I'm not saying it's a strong history, but it's there. So the science is not into manipulating, it's into facts. And here we're dealing with a little bit more than that, where they're combining a jaw of an ape to a head of a thing. And they say, like, oh, look at it, it's obviously, too different. So it puts me a little bit into and also how do you understand it? The people before the flood, the people after the flood, how did they look? There's a lot of different ways to understand it. Does it go against Judaism? Not at all. The Torah says there were worlds before here that were destroyed. There's many different answers that Judaism, that it could fit perfectly, even if evolution goes exactly the way they say.
So what do you mean that there were worlds that were destroyed?
So there's idea that God created worlds and destroyed worlds, and the worlds were created and destroyed, which means is that this is when dealing with the age of the universe, it is possible that you could say the universe is that old. Because and this is really a topic for the age of the universe, we're counting the age of the universe from the date of Adam Arishon, from his thing. What happened beforehand, there's a lot of different things we'll discuss, but it is possible that there were other things, over here that were created and destroyed, how many cycles we are over here. We'll speak about that all, that should answer you in the class about the age of the universe. B'ezrat Hashem.
What's the Torah explanation of how we look different all around the world? Asians look a certain way.
That is, the Zohar even brings it down. This is known that. So let's say you go to Africa or Asia. They look different than we look, in our side of the world. If you were to go into this other part of the world and you were to live there, wherever it is, Asia, Africa, you will look exactly like you are. But generations and generations down, the atmosphere, there's a whole bunch of different factors that come into play that the children are going to look more and more like that. They might become tanner and darker. They might come out and they might, Asians they might look more Asian-like. Well, that's interbreeding, of course that.
Sunlight, so you're obviously going to have darker.
Yeah, but I'm saying even the children will come out like that.
How many generations?
The proof is you look at. So
you all came from the same.
Right, and that's why you go in a room and you have people that come from Yemenite background, and people come from a German background. One is dark, one is white. They'd be like, oh, how did we all come from the same ancestor? The answer is because it depends. The atmosphere that you live in, it changes you. This is proven. This is not. This is already scientific. But you could already look at it. So.
Why are there so
I know it's redhead. I was just wondering the Torah.
It doesn't negate the Torah. The Torah agrees with that. That there is. This is the. Why they're redheads? What was the question?
What? For example, a redhead, in Israel, you would think everyone is all of a sudden darker because it's hot. It's it's warmer climate.
Right.
There's still people with light, fair skin.
They just moved there. Give them time. They made an aliyah.
Give them a chance.
You give them a chance. They just moved.
I guess
not
the
tan,
gingers,
feel like me.
they just become darker.
Over generations, not by themselves. They will remain the same skin pigmentation that they have, but generations and generations, as you get down, assuming that you're not even interbreeding I'm using the term interbreeding, but when you're breeding with the people from that darker descent, obviously the children are going to have that. But even not, the atmosphere, everything is going to come into effect, and it's going to make you have that. You look at people from Russia, different parts of Russia. One is darker, one is lighter. It's common nowadays, and they all have the same Torah. They all have the same things. It's perfect. It doesn't. Yeah.
How about you and me?
It was a mistake.
Any other questions?
Not
You have a
related
list?
to this.
That's fine. You want to go? Okay, you want. Go ahead. Somebody.
Off the camera.
You want to off the? Or go ahead. What's your question?
Off camera.
Nobody. Anybody other questions on camera? It's a shame people like the questions.
I heard your class last week and with people believing in UFOs, but there's been some stuff in the news about UFOs. Have you heard it? And have you
Define what in what
recently? Yeah.
in what particular aspect of it? What did we found? Extraterrestrial life, does it exist?
X-files that were discovered in the Pentagon.
So there happens to be that there is a lot of conspiracy when dealing with this. It's the same. You're dealing with the same people that are dealing with conspiracy about the Twin Towers.
Twin Towers?
The Twin Towers, that it was really just an inside job. It wasn't even. I've heard theories where people told me about this is not really this, and they bring proofs from left to right, from this to this. Is all. That's true. You'd never know. The question is, what is it? Torah's perspective of extraterrestrial life. I do want to speak about it for a time. It doesn't speak about it straight out, but it can be inferred that it doesn't. It is possible to have life on other planets, but speaking beings like us, it's very unlikely.
Okay. Oh, I have another question. I heard once that this Nachash was a dinosaur.
You could say that. There were large creatures that didn't make it onto the ark. There were creatures that didn't make it. That is known.
They weren't that bad?
No, they just didn't. There were creatures that didn't make it to the ark. It's like a known thing.
Crossbreed, and that's why they weren't allowed.
What the reason was, I don't know, but there were things that weren't,
Well, then how do we have a meal? So
I was going to say, people don't speak technically, like you said, non-speaking beings.
Not intelligent.
I was gonna say, and like technically the afterworld people don't speak that either.
Yeah, you mean telecommunicate. But I'm saying like more the intelligent being that we are, which is, by the way, another whole thing of evolution that we didn't even touch upon. Like, how did we come all of a sudden to have the ability to have, our mental capacities to build spaceships, like from monkeys? Like, where did that, like, random mutations? So where are we going to be in 100 million years? Are we going to be, are we going to be all levitating? Are we going to be all just like, it's like.
Yeah.
Well, that's what we know is going to happen, according to science.
Artificial intelligence, they're saying.
Yeah, okay, artificial intelligence is science right now.
It's going to be
In our brains.
Yeah, but then I could take some water report on the robot. There's a robot that has Arabic like citizenship as a human being there. Meanwhile, some of the Arabs don't even have like rights.
No, yeah, that was the last place in the world I think would get a artificial intelligence has a citizenship in a Arabic.
She was visiting. She was visiting from like another country, from Germany or wherever. She was visiting
an artificial intelligence.
Arabic country, and they were asking her questions, and they're like, "Well, you're welcome to have citizenship here."
Oh.
I bet she can't come to America.
There's nothing I can say to that.
So, people that like evolutionists or whatever you call them, and then observant people are like we all have skin in the game. Like if we're right, we are right, and if they're right, so they probably try to prove religion wrong. So do they say like, oh, the probability of Hashem coming and talking to this whole generation?
Right. So they do. Science does bring it down. We'll speak about that when we speak about the. Right now we're focusing on trying to prove that there is a God. After we get a God, we have to figure out what's the purpose. And after we got to figure out what the purpose, do we have the right religion? Maybe other religions are right. Maybe we're not right. So, and I'll give you a second. They do ask all those. Of course, they ask all those questions. They're known as, so there's evolutionists versus creationists. People who believe in the Bible, in the Torah. It doesn't have to be Judaism, Christians, Islam. They're known as creationists. They believe that there is a creation. Evolutionists believe in evolution. Now, majority of today's class that we spoke about had very little to do with specific Torah ideas. We dealt with it in a very strong scientific manner, which means is we use science itself to see if it's right or if it's wrong. Now, even if science is right, and we did come from one microorganism in one cell, it still doesn't negate the Torah. It doesn't go against. I mean, it's very unlikely because we have a lot of things that come into fact. Bereshis bara, God created the world. Adam created. There's a lot of factors that come into play. But just broad, straight out, there are opinions that say that it doesn't go against. It doesn't go against of what we what we believe. Scientifically speaking, it doesn't sound it. Some people say that if you believe it, it's kfirah, it's heresy, it's a heretic. There is an idea of it also, because if you're denying the fact that there is a God, then yeah, if you're going that far that there is a God, we know for 100% certainty that there is a God. 100% certainty. And that's the goal of this, trying to figure it out. This should lead you not towards an idea of like, yeah, we probably came from, this microorganism, which came from nothing, which we don't know, which which probability, it doesn't make any sense, to the other very simple answer that we were created. It should lead you towards that, direction.
What is next week's topic?
B'ezrat Hashem, I'm hoping it's for it to be the design of the world and probably other things, Jewish history. We'll pull with another, and then I want to finish off with the age of the universe. And that's the end of this part of the series. Yeah.
Is evolution still going? Is there something that comes after?
Of course, they think that. Yeah, of course. What's next? They don't know. Superhumans. No, there's going to be. Yeah, there's going to be. Yeah.
Tough to make it up.
Yeah. We didn't get there yet.
All right.
Any other questions? No other questions? Only off camera? Okay. Chazak u'baruch.
You've just experienced another Torah class brought to you by TorahAnytime.com.